so the first two are going to be graphing questions. The next 6 are going to be just straight up equations, raw, no stories. And then the last 5 will be in context. You'll have a story behind the equation. The equation, sometimes you just have to write the equation, and then sometimes you have to solve it. So read the directions carefully, and I'll point it out to you as we go through this game called 9.3, where everything is rational. So we're solving rational equations. So what's this difference? Remember, equations have an equal sign. We just got done with expressions, and equations have expressions on both sides. And here's where it matters about our, they call them like extraneous solutions. Did you get in yet? And we're going to talk about the no-nos. And before they called them asymptotes, and then they called them excluded values. And in this story, they're going to be called extraneous solutions. Because if we find an answer and it makes the denominator 0, then it's not really an answer. So here's number 1's equation. You could solve it with algebra, but they want us to see what it looks like on the graph. So in order to change this equation to a function on the graph, first of all, you have to see this, everything on one side. So you're going to add 3 to both sides, and it equals 0. Now that's the antithesis of we're trying to get x alone. What am I doing moving it all to one side? Because this equation on the graph signifies the solution. Whatever makes this expression 0 is the solution. But we don't want just the solution, which happens to be called the x-intercept on the graph. We want to know all the points that make this true in the real number system. So instead of 0, we're going to say, what about for all real numbers? What happens? So now this becomes the function to graph. And we're only doing a couple of them, but they want you to know they're connected. Remember, every algebra equation has a graph. And they want to show you on the graph where the answer is. But graphs aren't perfect. They're far from perfect. They're far from accurate. They just give us a bird's eye view. So that's why we wouldn't necessarily use graphs to come up with the solution. Using algebra is more efficient and more accurate. In a graph, sometimes you have to eyeball it. Is that 2.3 or 2.6? I don't know. So yeah, that's why we do have to experience graphing. But I'm biased. I would rather do algebra. And this is a complicated rational function. You could use Desmos to graph it. And I would just for the curiosity, I'd just put it in Desmos, see what it looks like. Then you can pick the right graph from the homework. But for this table, you've got to use arithmetic. Lots of numbers to plug in on that one for the ACT practice, there was only one number we had to plug in. This one you have to plug in 1, 2, 3, 4, 5, 6 numbers and see what comes out. Plug into here. So I would get my calculator, and instead of x, I'd put a -8 over -8 plus 4, and then plus 3 on the outside. So I'll just show you it's possible, but I won't go through every one. So I make a fraction. -8 is the numerator, and the denominator, it was a -8 plus 4. And I scooch it over, and then I add 3 to it. And then that's the output. So my y value is 5. That's what they want you to, you're finding the y values. And then you can just like grab this equation again. Instead of a -8, you could scooch back and put in your 6's, right? Scoot back. See how I did that? I'm lazy. I'm a lazy loot. So we got a 6 out, like that. And then on the homework, the software, you just repeat your output in an ordered pair. So you just put it in there where the ordered pair is. So I'm not going to, I did them earlier so I can do this quickly because the rest is just calculation. If you know how to do it, you got it. If you don't know how to do it, ask for help. There we go. So these are the ones you're putting in the y values. Any comments about how to make the table? You did that in Algebra 1, making a table for an equation. It's just you got to do it for this rational equation to find the solution. So after you get all that in, then you got to choose a graph. So I would choose like a couple of them to look for. I'd start here and look at my choices, see which one had a 0, 3 on their story, and I'll show you. See that the first choice didn't have a 0, 3. The second choice didn't have a 0, 3. Okay, this last one doesn't have a 0, 3. So that's all I needed to find my graph. So for me, it was graph C. So how am I going to write that in my notes? I'm going to put graph C. I'm just going to sketch. Went through 0, 3, right? And then it happened to go through a -3, 0. So there's got my one curve. Then my other curve just was, out like that. So just be, you can be, you can be sketchy when you do those things. So the last thing they ask on this number 1 is what's the x-intercept? Now on my graph, I could see it was a whole number. And I think your number 1 is a whole number. You don't have to guesstimate what it is. -3, 0. So the solution is the x-intercept. Solution is x equals -3. So these are the two. See how the graph went through -3? And once I picked the right graph, I could find the x-intercept from the graph. And so that's how you use a graph to find an answer. And you got to make sure this answer, since it's on the graph, it doesn't make the denominator 0. so I know I'm safe.
Hello, Mrs. Fisher speaking. Oh, I haven't seen it yet. Oh, sure. Well, I can't lie. Why not? Why? Oh, okay. Okay, but if you get them done tonight, I'll tell him you promised to get them done tonight. If he's asking for a response, what's he asking for? What's he want me to do? Anything? If it's true. Oh, okay. So that's true. Okay. I can say that too. Yes, I will say that too. They're in progress. Perfect. Okay, and so I'll be watching for your done email tonight. Thank you. Bye-bye. Silly girl.
Anyways, there we go. Okay, here we go. So if anybody watches this video, they get the goodie on the phone conversation. That's okay though. Number 2. Real life happens, doesn't it? Okay, I am going to have to go to a different page because I obviously don't have enough room for my table or my graph. So let me flip to the next page. Any comments about the table, graph, or why in the world is that the solution? Hopefully it's making sense from previous understanding, previous learning. It's just this is the long way around to solving rational equations. But it's just like anything, easy is earned. So we've got to feel the pain of graphing before we can enjoy the pleasure of algebra. Excuse me. Number 2, it's got an interesting complicated rational function. It is x equals 2x minus 4. I'm sorry, x over 2x minus 4 equals 3. And just like the last one, we can't talk about it on a graph until we make it into a function. So I have to scoot the 3 over by subtracting it from both sides. And then I have to create a function by making the 0. This is the solution, sloshing. And so x over 2x minus 4 minus 3 equals y. This is your function that you're going to graph. I want to know what's the pattern for all the real numbers. If I'm given this function, what's the output? Not just the solution to be able to do the graph. So they gave us a table with the x inputs. We're going to find the outputs and then write them as ordered pairs. They're whole numbers. 0, 3, 4, 6, 7, and 12. I almost made the bar long enough there. And when I put that 0 in my story, obviously I'm going to get a negative 3 out. If I put a 3 in my story, it does say on number 2 you got to round to the nearest tenth. I think 3 comes out to the 10th, so you don't have to round it. When I put 4 in, it comes out a whole number, negative 2. If I put 6 in it, I do have to round it to a negative 2.3. And then when I put 7 in, I have to round it to a negative 2.3. And so I looked it up. Oh, can 2 values have the same answer? And yeah, when you're rounding, that happens. And that's the problem with graphs, right? They're not very accurate. So when I put 12 in, I don't remember if it was an on it, spot on, negative 2.4 or not, but that's where I got my values. So my ordered pairs equals, just you repeat your y's in your ordered pairs. So it takes a lot of calculating time. Okay. Here we be. So I'm obviously going to use these two to I spy with my educated eye the graph. So 0, see 0, -3, yep, looks like he's here. But if I go 4 over 2, 4, it doesn't hit on a -2. So that one's wrong. Okay, 0, -3 is not there. Well, that's the wrong one. It happens to be C again. So I've got my 0, -3 and my 4, -2. Now you see how that guy is not easy to guess what the answer is? They've got a drop-down menu. So for your little graph, okay, it's 0, -3, and 4, -2. This one comes through that. This one goes through here. Am I still on the screen? Not very good. Okay. So this number is approximate. Oopsie. So on your choices for your x-intercept, the drop-down is clearly 2.4 and 0. Your other choices aren't close. So you won't, you know what I mean? You won't have, if you pick the right graph from your right values, you won't have to guess. It's a drop-down menu. And so your solution, x equals 2.4. So that's what they'll have for you to choose from. And that's why we don't necessarily care for graphs. So let's get into the algebra. I've got one more pretty before the time is up. Pretty fast. I just want to give you the framework for all, 3 through 8, if you're ready. No arguments, no wait. Okay, here's number 3 really quickly, and you already know how to work with fractions, so you're just morphing it over to the fractions that have variables in the denominator. So if I gave you an algebra equation that had fractions, and you had me for algebra 1, you would have heard me say a good fraction is a gone fraction. We want to eliminate these fractions by multiplying all terms in the equation by the least common denominator. And it's like magic. So what does 2x, 9, and 18x all go into evenly? Obviously, it's 18x. So if I take each one of these times 18x, cancel, and write what's left, I've gotten rid of the fractions. So if I take 2 out of 18, that's 9. X out of x is 0, so 9 times 9 is 81. If I take 18x divided by 9, 9 goes into 18 two times with an x left over. So 5 times 2x is 10x. And then 18x divided by 18x is 1, so it's equal to a negative 19. And bam! We got a good fraction is a gone fraction. That's what that's the moral of this story. We could solve this for x and find our solution. So we subtract 81. This is your Algebra 1 happy place. Divide by negative 10. I hope it is. Positive 10. Make sure it doesn't make the denominator 0. It doesn't. And this is the solution. That's 4, 5, 6, 7, and 8. Of course, our LCD is going to be so simple, but you do the same pattern. Just know a good fraction's a gone fraction. You multiply each one of these. I did it, half mental, half writing. So I took the 2x into the 18x, and what was left over, I multiplied by the numerator. So that's where I got my 81. I took my 9 into the 18x. I got 2x left over, multiplied by 5. I took the 18x into the 18x. It went to nada, 1. And so I just was left over with a negative 19. More practice mañana.